I am Ronit Datto. I am a student of MS with pursuing IoT and signal processing in the Department of Electrical Engineering. I am introducing you a 32-bit microcontroller. So what is a 32-bit microcontroller? You probably go through 8-bit microcontroller. 8-bit microcontroller calculates any tasks or calculates any performance.
Can you make full screen?
Okay, yes, sir.
Possible to make full screen, otherwise you can go like this.
Okay, sir.
Otherwise leave it.
Okay, sir.
Go slow, little slow. Okay.
Okay, sir. Sir, this is a 32-bit microcontroller. You probably go through 8-bit microcontroller. 8-bit microcontroller calculates any task and performance 8-bit at a time, and then it calculates, suppose 32-bit calculation, it performs 4 times, because first 8-bit, then another 8-bit, then another 8-bit, again another 8-bit. So this is total time consuming process, and this is too slow for high speed calculation. That is why we are switching from 8-bit microcontroller to 32-bit microcontroller. Okay, and due to this, the tasks of the performance of the system will be increased. So that is why we choose 32-bit microcontroller. It has 32-bit calculation accumulator, and it can calculate 32-bit data also. Okay, and this microcontroller capable to handle data processing, and it is capable to handle complex circuit performance. Suppose you have many sensors, many IDs is there, so you have to perform this very fast. So that is why you need 32-bit microcontroller. The code size of the program, if you write in 8-bit microcontroller, this is too high. Because of this 8-bit microcontroller, you suppose there will be any memory overflow is there, because of if you write any program in 8-bit microcontroller, there is a limited size of memory, flash memory is there. If you write a long program or complex program, it maybe happen that 8-bit microcontroller memory is not sufficient to write this program, right? And for 32-bit microcontroller, the flash memory size is many more with respect to 8-bit microcontroller. For 8-bit microcontroller, Atmega 328P, it has flash size 32K. For 32-bit microcontroller, if we use ESP32, it has 4 MB 4 MB flash memory, 4 MB to 16 memory if you choose any this model number. So it vary from 4 MB to 16 MB. So you compare 32 KB to 4 MB is too large. Okay, so you can write a large program and complex program is there. Okay, you have any questions from this? Why we are choosing 32-bit microcontroller? Okay, I am go ahead. So we are choosing 32-bit ESP32 microcontroller. ESP32 is a low-cost system-on-chip microcontroller. It is famous because of it is using the same architecture with modified architecture, not same. ESP8266. ESP8266 is also a 32-bit microcontroller, but it is a single core microcontroller. But ESP32 is a dual core microcontroller. So this helps us. It has 2 core. One core is calculating our main program, and another core is supporting the wireless functions, wireless sensors, mainly Wi-Fi, Bluetooth, and other peripherals are there. One core handling other tasks and another core handling our main program. So that is why the speed of the calculation will increase, and it has 240 megahertz. Sorry, 240 megahertz. Uh, uh, Clock speed is there for 2 core. Okay, so it is 32 bits. It is a LX6 microprocessor is there, integrated with Wi-Fi and Bluetooth. It has 2 main solutions. That is why we are choosing ESP32. is designed for mobile and wireless electronics because of its ultra low power solution and Internet of Things applications. It features all state-of-art characteristics of low-power chips, including fine-grained clock gaining multiple power modes, dynamic power scaling. For instance, in a low-power IoT sensor application scenario, is there. If we want to use ESP32, ESP32 is a very much suitable for this application. Okay, this is as low duty cycle. Okay, so that is why.
Sir,
Okay, okay, please.
sir, did you change the slide? Like we are still on this slide number 2.
Yes, I have changed.
So like slide number 2 is visible for all of us.
Okay,
Yes, sir. Next slide, sir.
I have changed only one slide. Okay, what is ESP32? I have just changed. So this is visible?
No, sir. We are still on 32-bit microphone.
Okay,
Yes.
okay, okay, okay.
Rohit, I think if the slide is not progressing, you now it is changed.
Okay, sir.
Yes. Now it is what is ESP32 coming.
Okay, okay, yes, sir, yes. So this is suitable for us. So when we are using full screen mode, so slide will not change. So okay, so I am going through in this fashion. So this is ultra low power solution is there. Because of this ultra low power solution, we use ESP32 because of it is run with 3.3 volt voltage source, and it will take low power to transmit the data from that device to internet. So that is why we use this ESP32 microcontroller. Okay, so there is IoT based things is there. We mainly prefer ESP32. And second thing is it is complete integration solution is there because of it has Bluetooth, it has many communications protocols is there, UART, SPI, I2C is there, and also it has onboard ADC is there. In with compared to Raspberry Pi, there is no ADC, and ESP32 is onboard is ADC is there, and also other peripherals are there. We are talking about that in the next slide. What are the main features of the ESP32? Why we are choosing this ESP32? These are the specifications of ESP32. This is dual core processor of 32-bit microcontroller, and each has 240 megahertz clock speed. Okay, and it compared to our normal Arduino Atmega 328P, it has only 2 KB RAM. 2 KB SRAM is there, but here we see 520 KB SRAM is there, 448 KB ROM, and 16 KB RTC RAM is there. Okay, so this is too high to calculate the real-time operation. If we want to use SRAM to collect the data, and then we can process the next calculation. If we want to collect the data simultaneously, more number of data, so we can use SRAM. If we use Arduino, it is also possible, but overflow condition will be there because of this is 2 KB, this is too low, and this is 520 KB. So it has more power to store the data in a real-time fashion. Okay, when we write a program, suppose we write int an array, int and variable. When the program runs, this variable stores the any data. If integer type is can be float type, it can be character type in SRAM. Only SRAM you can store this data, and after storing this data, you can permanently store in EEPROM. But when we are calculating or when we are going through a program, it is running in a while loop again and again, it only use SRAM. If you want to store more number of data in an array, suppose you want to store 100 integer type of data in an array, so you need more amount of space, SRAM, to store this data, because if you want to store an integer takes 2 byte of data. 2 byte means 16 bit in a fashion. So 2 byte of data is there. If you want to store 100 values, so you need 100 into 2 means 200 byte of data. So that in this fashion, the RAM will consume is space. Okay, so if you want to take 1000 or 1500 amount of data at a time, and then you want to calculate further, you first you take all this data, so you have to select a processor in this fashion. It has more SRAM. If what is your need, or what is your purpose, with respect to the purpose, you have to choose your microcontroller, right? And then it supports 802.11 Wi-Fi connectivity, which is our normal our mobile hotspot, and also we have our Wi-Fi network. Normal Wi-Fi network is there. This has connectivity up to 150 Mbps. It can transmit and it also can receive the data. Okay, this is it has the architecture. I will show you what is the Wi-Fi hardware is there. Okay, it supports Bluetooth. Also, it has inbuilt Bluetooth on its microcontroller chip. It has Wi-Fi and Bluetooth in this. With this power, we can use IoT platform. And also, it has 34 programmable GPIOs. It has 34 GPIOs pins. General purpose input-output pins are there. And it has, I told earlier that it has ADC. It has 12-bit ADC is there, and its sampling rate is too high. This sampling rate you can achieve from 0 to 200 kilo sample. If you go through your this data sheet, you can achieve 200 kilo samples of data with help of the ESP32, because of its high clock pulse or high clock rate. And when you are using our normal Arduino IDE, Arduino means Arduino Uno IC Atmega 328P, it has a clock speed 16 megahertz external crystal is there. So it has 128 P scalar. When the ADC works in this fashion. When you are applying a clock, suppose 16 megahertz clock, and then 128 P scalar means this divide the clock rate with 128, and then it will apply to ADC. ADC is taking, suppose I thought over 12 clock to generate a data. So you divide again, divided by 12, and you can get 9600, means 9.6 kilo sample per second. Okay, you are going through the PDF of Atmel. You can get this data very clear and very elaborately. And also it has 12-bit, also it has 8-bit DAC, serial DAC is there. Also it has 4 SPI, 2 I2C, UART, I2S is there. And we explore all the things not simultaneously. We explore something from this ESP32 in today's class. And again, we will find out and we will explore all the peripherals and performance is there. Now, today we are going through ADCs, and we are going to UART, I2C, these protocols, and Wi-Fi, also Wi-Fi cloud-based things we are going through. Okay, and it has also PWM, because PWM means pulse modulation, is a fixed time period. You can change the duty cycle, T on and T off time. So even in this way, you can change PWM, and it helps motor rotation speeds, and also LED PWM, LED brightness you can control. Also, it has secure boot and flash encryption. I jot down here not all the specification. I note down here on this specification, which is something usable to us in this class, and which is not all the things, which is mainly common, and mainly this is very basics you have to know for choosing the ESP32. Okay, and then it has a block diagram. So this block diagram, we said earlier that core and memory is there. It has 2 or 1 core. 1 core means if you choose ESP8266, it has 1 core. If you choose ESP32, it has 2 core. 2 core processor, each one 240 megahertz. Okay, it has ROM and SRAM. we said earlier that it has SRAM of 520 KB. Okay, and it has ROM. I said I have not note down here. I said that it has ROM 4 MB to 16 MB. If you choose the model number, then you select 4 MB and you can select 8 MB and you can select 16 MB. It has 3 variants there. Okay, so ROM and SRAM is there, and I said that Wi-Fi MAC is there. Wi-Fi baseband is there. This is 2.4 gigahertz Wi-Fi baseband, and we use these Wi-Fi signals, and we use our left-hand peripherals like ADC we will use today, and we will use I2C protocols. We will use UART protocol, and or other protocols are there. Touch sensors is there, timers is there, DAC is there. We will not explore today. We will explore later. But there are these types of hardware, and this type of performance is inbuilt with a single chip processor. Okay, so that is why we are choosing ESP32 microcontroller. So now, different ways to program it. How to program ESP32 microcontroller. So
I have one question.
you're right, sir.
I have one question to Abhijit. Abhijit, are you there?
Yes, sir.
What is the advantage of 32-bit controller over 8-bit controller?
So the main advantage of 32-bit controller is that we can perform calculations. We can perform calculation using large numbers at a time. Like it can handle 32 bits, whereas Atmega can handle only 8 bits. So you have to, it has to do.
In one word, can you answer it in one word?
Yes, sir. For calculating large numbers, Atmega 32 no,
Also
sir.
small numbers.
This 32 bits.
Also
yes,
small
yes,
numbers.
yeah, for small numbers as well. So
Okay.
it.
Okay. What is the advantage of 8-bit controller? Harsing. Harsing, are you there? Harsing.
Yes, sir.
What is the advantage of 8-bit controller?
Like over which, like over 32-bit
Over
controller.
32-bit controller. Arpan Dev.
Yes, sir.
What is the
Sir,
advantage of this 8-bit controller over 32-bit controller?
So I think that when we don't need large numbers for calculation, we can use 8-bit microcontroller because it is like less costly than
Less costly or
32-bit.
anything? Major advantage is what? Cost is one factor definitely, but what is the major advantage? Who can answer? Please raise your hand. Please raise your hand who can answer this. Okay. Nausin, Ajay, Nandakishore, please answer.
Sir, the 8-bit controller can perform more operations than the 32-bit controller.
No, that's not right. Okay, Nausin?
Lesser power consumption.
Yes, very good. Nausin should get a star, Pooja. It is less power consumption. And the first answer was accuracy. We'll talk about it. Okay, please, Ronit, go ahead.
Okay, sir. So we have different ways to program ESP32 microcontroller. So we can use Arduino IDE platform, and we can use platform IOID, and we can use LUA, MicroPython, ESP, Expressive, which is the generation or which is the develop this microcontroller. So this IDF is also there. JavaScript is there. So we can program it with various programming IDE platform. So if we are simplifying and if we want to go through very fast and we want to grab more things, so we can choose Arduino IDE. Arduino IDE is very friendly programmable environment. So that is why we are choosing Arduino IDE to program this ESP32 microcontroller. Okay, and this is the ESP32W model. It has various variants are there. ESP32 Rover is there, which is its upper version. ESP32 W Room's upper version Rover, and we use ESP32, and its laser version is ESP8266. It is also 32-bit module, but single core. It is double core. So we can see that here it is a single chip microcontroller. It contains all the peripherals, all the sensors. The sensors means this is touch sensors is there, and Wi-Fi Bluetooth module in a single chip. So it has very tiny shaped PCB which is mounted like this, and it has, these are the pins, output pins are there, the left and bottom and the right side. There are GPIO pins, voltage ground pin, enable pin, boot pins are there. We have may not seen these things because of if we want to find out ESP32 development kit, it is placed in a PCB and with a UART protocol. UART means FTDI. FTDI means serial to USB to TTL converter is there, serial to TTL. So this converter connects with this ESP32 and make a single PCB to program it very easily. So that is why we are not seeing like this. This is a main microcontroller on this PCB. Okay, this is the main microcontroller. These are the all GPIOs 36, 39, 34, 35 is there, and also it has ADCs.
So this one they will buy. Which one they will buy? They suggest them one link.
Yes, sir. Yes, sir. I will suggest you which one they are buying. They want to buy. So this is the main chip. We will not buy this because if you buy this, then you have to customize your board. I can show you how to customize it, but you will not buy it now. You buy it, the total the development board. The development board is like this. This is the development board. This development board, this is the USB port. USB micro USB is there. You can means OTG port is there. This is boot pin, boot switch. This is enable switch. This is the inbuilt FTDI programmer is there. USB to TTL converter. From TXRX you can program it. This is 3.3 volt voltage converter, because this IC runs with, or this microcontroller runs with 3.3 volt voltage. So that is why you can use this ADS 11117. This is the 3.3 volt microcontroller is there, and nothing else is there, because and one is the LED, the onboard LED, and one is user LED is there, and this is the main chip is mounted on this PCB. So you can find it on Amazon, on the Robu, and there are various websites like Flipkart. You can buy ESP32 WRM room WRM32, the development kit. This is the price from 400 to 600. Various website is there, 400, various is 600. The price varies with respect to the flash memory. If you want to use large flash memory like 16 MB is there, so you can then the price will be more, and if we use 4 MB, then price will be too less. Okay, so I will share you some link. The link is there. I will show you later. So now I am if you want to use this IC as a customized format, so you can use ESP32 like in this fashion. If you want to use your own PCB, like you want to use you want to design your own PCB in Eagle, like EasyAda, and various platform Altium is there, and you want to use ESP32 your main microcontroller, and you develop your main PCB, a conditioning board is there. So how to you use this specific chip to make your customized microcontroller? You can order this your design board to any of the PCB companies like PCB Power is there, and very famous GLC PCB is there. GLC PCB is not Indian.
Rohit, can you
yes,
share
sir.
the manual of ESP32, a good manual where they can get more information?
Yes, sir. Yes, sir. I can share. I am stop sharing. I am sharing my full screen so that you can see. This is ESP32 technical reference manual. You can go through this. This is the system. This is the content there. This is the talking about SRAMs and clocks. What are the memory management addressing management there? The catch block diagram is there. I took here the internal block diagram I took from here. So this is the technical reference manual. If you search like this ESP32 manual or data sheet, ESP website can provide you, especific.com will provide you this data sheets. Okay. This is smaller version of this previous. This is to elaborately describe all the things. This is 718 pages, and this is only 68 pages. They just jot down the important things, and they elaborate, not elaborate all the things. They elaborate something which you can understand. Okay. The main things, what is the purpose of the security advanced peripheral interface, clock timers. This is the main block diagram I have copied from here. So this is the technical references. This is the data sheets. Okay. If you can search ESP32 manual, then you can get this longer version of the manual. And if you search ESP32 data sheet, then you can get only the data sheet. Means the shorter form of the manual. Okay, sir. Now I am telling how to.
Do you have the layout of the demo which you want to give?
Yes, sir. Yes, sir.
You can show them the basic work which you are doing.
Yes, sir.
You can show also the device, how the device is and where you are connecting it.
Yes, sir. Yes, sir.
You
I
can
am
show
showing.
if it's possible. Yeah.
I am showing. This is visible from the camera.
Yeah, it's visible.
Yes. This is ESP based customized board. There we are using ESP32. This is the main chip, ESP32. If you want to ESP32 development board, then you can use this. This is ESP32 dev kit is there, development board. Okay, this is the development board. This is more user friendly, this development board, and this is our customized PCB is there For this
No,
customer,
ESP is the small one. That is the IoT processor. Processor
Yes.
with IoT. Because there are other processors also with IoT.
Right.
ESP is very popular and cheap, but there are many other processors with IoT. What is IoT? IoT is a protocol, actually, a software which can be used as a web server. You can use as a client. You can tell them about this, just like a PC.
Okay.
And it will connect to the Wi-Fi standard, which is IEEE some 802 or something standard is there. So this Wi-Fi protocol runs there, so that you can connect and send and receive data. So you can also do by Bluetooth, but Wi-Fi goes little, the far distance. So Ronit, you just explain them these things. There will be a quiz at the end of the class today. Whatever he taught, he will ask 5 questions you have to answer.
Okay, sir. Thank you, sir. So now I will show you how to program this customized chip and how to program this board, and I will show you. Okay. So now, if you want to program this customized chip, if you need a FTDI programmer. FTDI programmer is this. This is FTDI programmer. This is also named as a USB to TTL converter is there, and there is a I'll show you. I'm showing you. There is a pins. Various pins are there. One pin is TX, and another pin is RX, and another pin is ground. Which three voltage, two transmission pins and one ground pins is there. This is required. Program this ESP32 chip, and this is here. This is the one pin out is there. This is it has 3 pins. One is ground pin, and another is TX pin, and another is RX pin. When you program this chip, you have to connect the RX pin of the FTDI programmer, here TX pin of the ESP32, and TX pin of the FTDI programmer, you have to connect RX pin in the ESP32 chip, and ground to ground you can connect with the help of the jumper wires. Okay. Now I have connect these jumper wires. If you can upload this through this FTDI programmer with this ESP32 chip, in this ESP32 chip, it will not happen because you have to enter the boot mode. If you don't want, if you are not pressed this boot mode, so this chip will not be performed as a programming mode. This is the your ESP32 development board. It is not required here. It also has boot and enable buttons is there, and enable or reset button is there. It is not required because of it has USB to TTL converter. This is the chip. This is the chip. Another chip is there, USB to TTL converter. This chips has DTR pin and reset pin is there. This is connected to reset, and DTR pin is connected to the enable boot pin. So that is why it is not required for this development board. But in this our customized board, it is required to enter in boot mode. So how do we get this boot mode? I am showing you in this presentation, and similar thing I will do here. Sorry. You have to connect. This is the boot pin. This is the boot pin.
I have a question for Ajay Mishra. Have you seen any IoT devices?
Yes, sir.
Tell me one example.
Alexa.
Alexa.
Yes, sir.
Alexa, okay. Industrial or practical IoT?
Practical IoT, maybe mobile phone can work as a IoT or devices in car.
Yeah, they have separate standards. They generally do not connect to IoT, otherwise security breach will be there. We'll talk about it. Okay, you go ahead. So Ronit is giving an example. You see that's a kind of IoT.
Yes, sir. So you have to connect here with a resistance. Suppose 10 kilo.
वो जो पावर पॉइंट थोड़ा दिखा दो, नहीं तो मैं दिखा दूं क्या उसको? I will
Yes,
show
sir.
you that. I will show that picture. Okay, don't worry. After some time, you finish and then I will show if necessary.
Okay, sir. Okay, sir. So this is 10 kilo and 3.3 volt power supply is there for enable, because of this is enable active high, and this is the boot pin. It also you have connected 3.3 volt with 10 kilo. This resistance is required for entering in boot mode. How? Just you have to connect a push button. This push button is there, and this is the ground pin. This is the push button. When you press this, this is be grounded and it will enter the boot mode. So when we release this button, you, just it goes to 3.3 volt suddenly. So that is why you need a PF capacitor with parallel with this, such that suppose this is a 10 nanofarad capacitor. I want to voltage like this. This RC, this is the R, this is the C. This is the RC coupled, RC network. So we want to use in this fashion. Then that is why otherwise the hazard will generate. So that is why when you use push button parallel with a capacitor will need it, and it is the same fashion. We use a push button here and parallel with a capacitor. This is 10 nanofarad capacitor. When you press this both the button if you press, then it will enter in boot mode. Both means enable and boot. Then it will generate boot mode. When you release enable and hold boot, it will flash the memory. The flash performance, this will happen. Entering pressing the boot mode, release the enable button. Okay, and you have required the 3 pins for the programming this structure. 3 pins means the TX RX pin, main TX RX. TX RX means this TX RX and ground pin. Any of the ground pin you can use this. We can use this TXD, RXD, and ground. So you can use like this. This is TXD and RXD. TXD, RXD is there. So TXD0, RXD0, and the last one is this is the ground pin. Okay, here you can use TXD0, RXD0, and ground is, and the above is the ground. Sorry, this is the, and I saw earlier, this is the development board and this is the chip. This is TX RX and this is ground, which is 1 and 1 2 3 4 5. No, not this. 1 is ground, 1 2 3 4 5, TX0, RX0. We have to separately make like this with a bud stick. You have to connect your USB to TTL converter USB to TTL, FTDI programmer, like this, ground to ground, and RX to TX, and TX to RX, and you can program this chip. Okay, I'll show you how to program this chip. We take any of the program like this. We want to take a Wi-Fi program. Okay, we want to program is Wi-Fi mode. So we can use program. Suppose we can use access point. Access point means Wi-Fi means you want to use your web server. So you have to create access point. Access point means the this chip transmits a data, means a Wi-Fi network. Then this network you can enter like this when there is any Wi-Fi router is there. How you connect this router with your phone and with your laptop? You can search the Wi-Fi network, and the name will show is there, and you put your appropriate password, and then the network will connect it. So it is the same fashion. You can use this Wi-Fi chip as a access point. Access point means you can generate the Wi-Fi transmitter is there. You can connect this connect with various your systems with the Wi-Fi channel through it, and you can show your data in web server, and it has various applications is there. So I am showing you how to create access point. If you first open your ESP your Arduino IDE, then you have to select the preferences. From where? From file, the preferences. You have to put this link. If you are not put this link, the ESP32 board will not showing. This is the board manager. This is the AVR boards. AVR means Arduino platforms, Arduino's various boards are there. This is the ESP's board. Okay, if you are not put this URL, then ESP's boards will not be there. Where you find this URL? Just search in Google like this. ESP32 Arduino URL. Okay, and then open a link. Any of the link you can open. There is various methods are there. There is a URL. You have to copy this URL from here, and then we will go to ESP Arduino IDE, and then you have to go to file, then preferences, then board manager URLs, and paste it. Don't remove any other if there is a field any other links or URLs, don't remove it, just enter it and paste it, because this is same, so that is why I removed here. If this is not same, if you want to use any STM boards, there STUnio is there, and if you are use Launchpad Texas Instruments boards, okay, so you have to put this URL here. Okay, so now you will click OK, and then OK. Then you have to search tools, board manager. You have to search. Now waiting something. Then search ESP32. Okay, I have installed this. You have to install ESP32 version, ESP32 libraries. Otherwise, This program will not be flashed, will not be compiled. You write this program in high level language, you have to compile this in machine level language to generate machine level language, then you can upload. Okay, so this library function helps you to generate high level language to machine level language. Okay, then you put the install button. This takes a few minutes to install this software. Then you write the program in high level language and assemble it and compile it, and then you can upload it to your ESP32 module. Okay, please. Hello, please.
Yes, so this coding you are doing for ESP32 development board or the like customizable chip?
Right, you can use both. You can use this code both. If you use customized board, then you have to perform the boot mode. If you are not using customized board, just plug your OTG cable to your ESP32 development board and connect it to your USB. If you are using your customized board, then you have to connect USB to TTL converter. Is the middle middle chip is there, and which is converts in USB signal to your TXRX signal. Then you can flash your board. Okay, this code is same for the ESP32 customized chip and ESP32 development board. The main thing is that when you are using ESP32 customized board and when you are using ESP32 module, you have to select. When you are going to a product, then you have to use ESP32 customized board, because of you don't want to generate a very large PCB, because of a development board has various GPIOs as there. You have to connect this in the rail of bar stick. Bar stick means there is a stick which are male and female is there. You can put there, and it has onboard FTDI programmer is there, which is not required. You flash it one time and you can sell it, and you can use it for the longer time. So that is why you can use your customized board. You don't use
in the message box type how to install this. They have Arduino, but they have to add this device, I think, right?
Right, sir. Right, sir. You have to write.
All of you can type the website link from which they will buy it.
Yes, sir.
Sir, like in during the first class, like we were instructed to buy ESP8266, so we bought that actually.
Okay, no problem.
ESP8266. You will give the link. You buy it.
ESP32 development board is there. I prefer Amazon. When you can use a Robo also. These 3 websites link I am showing you and giving you. This is trustable website. We are purchasing all our lab components from 3 websites.
You guys buy all these things and consolidate all the bills and give it to the lab. Okay, your class representative should consolidate all the bills. You sign all the bills and bring it to me.
Oh, sir.
Yes.
So, like those who have already bought the ESP8266, should they again need to buy the ESP32?
No.
No, you can use that USB, no problem. Those who have bought already, you can.
Okay, sir.
ESP8266. This is the ESP8266 Node MCU board. You can buy it if you want. You can also buy it.
No,
I am not.
What? Can you just write down that? That's also fine.
Sorry, sir, I am not.
They have actually. I told them to buy one different kind of ESP. I think a little bit, but similar, not much different.
Yes, sir. Yes,
ESP8266 is only, I think.
Yes, sir. ESP8266. Okay. So ESP8266 is single core. ESP32 is dual core. ESP8266 does not contain Bluetooth. ESP32.
As far as coding is concerned, it is not going to make.
It is not required. we are only focusing on IoT platform, that is Wi-Fi is required, so Wi-Fi is there. So that is why this is not problematic situation. So you can, so I am continuing the ESP32 programming, Wi-Fi programming. So first we want to create access point. So how to create the access point? After including these links and board managers, when we select the board manager, I'm going from previous. This is your UNO. This is your UNO platform. Okay. The UNO board is selected. When you are installing board manager ESP32, then this ESP32 Arduino platform will be there. There are various types of boards, ESP based. Note down, if you use ESP32 dev module, then you click with this ESP32 dev module. Those who are using ESP8266 module, then you have to select ESP8266 V1 or V0.5 is there. ESP8266 is not ESP32. This is not the link of ESP8266. I'm showing you how to install ESP8266 links. The same way, ESP32, not this ESP8266 Arduino URL. We have to paste it. Just copy it, the link, .json link you have to copy and then paste it, file, preferences, don't remove it, just inserting a comma, or you can click it here and press the enter button and paste it. Okay. Then you have to go tools. Then you have to
this
go
record of this whole demo, can you upload in the chat box, those who are recording? Okay.
And if you are getting some problem to if you are any question how to get, you please ask me. Okay. And then you have to wait something. And now you have to press enter ESP8266. This ESP8266 module I have not installed because I'm not using ESP8266. So we have to click here and latest version we have to select, then install it. You have to wait sometimes to install its libraries. You have to wait some time, completed its installations, then close it and select from the tools, not ESP module. You have to select ESP8266 board. ESP8266 board have many variants is there. One is tiny ESP8266 board. It has only 8 pins are there. You must buy your Node MCU module, right? So for Node MCU module, you have to select it. You have to check it, the version of your Node MCU module. This is printed on that board. Okay, this is 0.9 or 1.0. If it is not printed on that board, first you select your Node MCU 0.9 and you just upload blinking program. If it uploads successfully, then your board is 0.9. If it is not uploading, it generates a flag throwing an error. then you have to select NodeMCU 1.0 versions there. Okay. First, what I am telling, if it is printed, it is okay. It is not printed, then you have to upload a single program. If it is uploaded successfully, then your version, you have to note your version. Okay, if you are not capable to upload this program, then you have to change the version and then you have to try to upload the program, right? Any confusion is there? So yes, we are using ESP32 dev module. So now the program for ESP8266 and ESP32 will be same. You have to concern on this program how to write it. You don't have to concern the what is our chip ESP8266 and ESP32. The library will generate your machine language code from high level language to machine level language. You don't have to worry about that, how to convert our chip is single core, our chip is dual core. You don't have to worry about that. Okay. So then when you are writing this code in this fashion, when you are using Wi-Fi, then you have to install Wi-Fi libraries. If it is pre-installed, okay. If it is not pre-installed, you have to install it. How to install? You have to go tools, then not board manager. This board manager only for this board. I am using 3 boards, so that is why it is showing 3 boards. Then you have to go manage libraries. This manage library from top to 4 flashing points is there. This is manage library. You have to wait because of it is checking your install library is updated or not. Here you have to find Wi-Fi. Okay. Press enter. This Arduino Uno Wi-Fi dev ED library is installed. You have to install this library because of I am using this library. Okay, this is ESP8266 based and ESP32 based functions. Inbuilt functions is there. We can use it. So you have to install this library. If it is not installed, if already installed, then close it. Okay. Then the program is #include wifi.h. You have to include your header file to use its inbuilt function. Then in voice setup, I have just serial.begin is I have written 9600. This is nothing but baud rate. Baud rate means bits per second. This is a UART protocol, Universal Asynchronous Receiver and Transmitter Protocol. So this protocol has no serial clock. This has no serial clock. So that is why you have to tell how many bits are going from one side to another side. Okay. If transmitter and receiver baud rate is same, then you have to you able to have to collect the correct format. You can think is like this. If you are sending suppose you are ordering any online material, a message you that these things will going to you and in this date. This is the tracking process. The baud rate is nothing but a tracking process. If you send the 9600 baud rate and you are receiving 200 in baud rate, the receiving file will not same as the sending file. This generates a garbage value, nothing else. Okay, so that is why the baud rate we have to set for UART communication. Just we want to see here with our access point how many devices are connected and what is my access point IP. Okay, so first you have to enable we have to use Wi-Fi.soft-AP. Soft-AP contains 2 things. One is your access point name. That is why that is same as when you are configuring your router, the router name is there. This is the nothing but a router name. The access point name is there. So when you are just configuring your router, this is the same thing is there. Access point you just change your the name of the default access point to your customized name. Suppose your name and your favorite any name you can put. So here is also you can place any name. I use ESP. One can use IIT KGP. Okay, no problem. So you can use IIT KGP, and then you have to put password. The password length should be 8. If you are using 7-bit password, no error throwing will be there. The only thing will be happen. It is when you are searching this network, it will not a secure network. Okay. Anyone searching this network and clicking it, and he can join. He or she can join with this network. So that is why you have to select minimum 8 length of character password will be there. Okay, I'm writing here minimum 8 length of password strength. Then it will be secure. This is 8 1 2 3 4 5 6 7 8. This is secure, and we want to see our in serial monitor. This is the serial monitor button. This is an busy because of I am here using COM port 4. So I will show you later. So this is the serial monitor, or you can go from tools to serial monitor. We want to see what our access point IP is.
Please order the DSP to those who have got the ESP, fine. Those who have not got it, please get it, because again Ronit will continue maybe next week. Okay, next week Monday, do you have class or it is suspended?
I don't know the
Suryadip,
suspended or.
what about next week?
Sir, I think there is class.
There is class. Okay, so next week we'll do the online demo here. Okay, then you will do in the lab. So please try to get everything. So this kit has got onboard sensors, right? Humidity and temperature.
Yes, sir. It has onboard temperature and humidity sensor on board.
So you have to send the onboard sensor data to a internet site.
Yes, sir. I am using ThingSpeak.
Yeah.
I'll show you. I'll show you, sir.
Okay.
Then you have to know what is our access point IP. So this is the just message serial.print access point IP, and this is the function Wi-Fi soft API IP access point IP internet protocol, and this is the function. This function just prints what is our access point IP, and this loop is continuing going on. This is just a continuous infinite loop. They will show how many number of devices connected with this network. Okay, the number of connected devices, and this is the print the cl.println. This is the number Wi-Fi.soft AP. AP means, as I have said, access point get station number. Just show you the number, how many devices are connected. Yep, inserted here a 5-second delay, because of if we are not inserted delay, this message will show many times. I don't want, so that is why I have inserted a delay. Now I am going to upload this program with ESP32 development kit. I am using just development kit. I will show you later how to flash this customized board. This is very interesting. Now I am just want to use Wi-Fi to our development kit. This is our development kit. So I am going to use. You have to stop this COM port to upload your program. Okay, if you are not cross this COM port, serial monitor will not open, because of this message will be flashed. The COM port is busy. Okay, so that is why you have to close your COM port, and you have to select your common port number. If you are not able to get what is the will be your COM port number, COM port 1, COM port 3, or COM port 4, what will be your COM port number. Then you can go with this PC manage device manager ports. Here this will be show. This UART bridge, USB to TTL converter, CP2106 will be possible, 08 will be possible. There are various silicon chips for USB to TTL converter is there. This is inserted in common 4. So that is why we are using common 4. Okay. Then we have to go there, tools, just common port. And previously we have to select it ESP32 dev module. This is 40 megahertz processor. I have already told the flash frequency. You can flash 40 megahertz. This will be slow, and 80 megahertz. This will be the problem. This flash size of my chip is 4 MB. Okay, this is various variant. 4 MB, 8 MB, 2 MB. I think is not there. 16 MB is there. Just click here. Verify. Verify is this compiling is there. Your program is correctly written or not. Just wait something. Sometimes required to compile it. It takes some times because of this is Arduino platform. The main middle library is there, which is converting this high level language to your target based machine level language, then compiling, then you can load it. When you are uploading, this compiling process is again will be there, but this takes smaller time because of already it is compiled. Just verified it. Starts to program flashing flash memory. Okay, it has completed the flashing. Done uploading, message is flashed. Then you have to open serial monitor. When you have opened your serial monitor, the upper void setup part is all only one time is had been one time is had been executed. So that is why you are not getting Wi-Fi IP, that is access point IP. It is it starts the number of connected devices. So this is the problem. How we will get? Just click enable button. Enable means reset button is there. Just press it. It starts from previous. Just is press means the program counter goes at the 0000 address. 4 times 0, 32-bit is there. 4 times 0 is there. So when it starts from the previous at the first main memory, then it executes one by one, and then this prints serial access point IPs. Okay, here our access point IP. Why this is needed? This is needed to server to generate your web-based server. This is needed. Number of connected devices 0. I have not connected any devices. Now I am showing you my phone, and I want to connect my phone with this device. Just I have searched. It is showing IIT KGP. Here it is visible.
Actually, the screen is blurry. Like
Okay. This is IIT KGP. Okay, the third. So this is secured. Just I am clicking and inserting 8 times zeros. This is my password. 1 2 3 4 5 6 7 8. Just clicking connect. Connected. And flashing. Number of connected device 1. Right. If you want to connect your laptop, then it is also possible. Okay. Now I am connecting my laptop. Is you are just checking the number of connected devices will be 2. Okay. Now I am connecting my laptop. Yes, the connected devices is 2. It is flashing. Number of connected devices is 2. This is the basic access point generation. After generating this access point, the further tasks will generate web-based server. Web-based server. That is why. Yes.
So like with this access point like programming, like can you like permanently change the password of the like I like that Wi-Fi? Like if we disconnect the Node MCU board, like the password will be like revert back to the original earlier one, or it will remain the same, like the
Will
one
remain the same. It will remain the same because of the flash memory. Flash memory will not be erased. This is permanent. If we want to again flash it, then you can change it. Otherwise, it is remain same. Like this, if you are program your chip and you have turn off your power, and again you have connect this power, then the program will going the same program you have to you have uploaded. This program will run again and again. You have just noticed it, right? So in this fashion, the access point name and password will be the same, right? The also access point IP will be the same, and sometimes it can be changed. If it is changed, then you have to open your compute. You have to see what is your Wi-Fi access point IP, and just put it your web browser and just your mobiles, and then you can connect the same access point network. Okay, you don't have to program it again and again. You have program one time, that is sufficient, right?
sir, and like can it access like any Wi-Fi? Like we cannot set any Wi-Fi password, right? Because it's like some kind of secured or other people's Wi-Fi. So we cannot like. Can you change that password also? I don't
Yes, sir.
like.
Yes. You can change the password. You have to program it again. Now we are using 8 times zeros. You can change it. You can change it 1, 2, 3, 4, 5, 6, 7, 8. Then you have to upload again. Then you can upload your program. Like router. If you want to change the router password, then you can go to the router settings, and then you have to change your password, and then just save it, right? Your query app cleared?
Yes, sir. Yes, sir.
Okay. Just this is the access point. Now I am.
Sir, I have a doubt, sir. Sir, with this ESP32, are we connecting it with an external Wi-Fi, or is it creating its own Wi-Fi network?
Yes, I am going to your question. This is our next program. Our next program is the,
it has to. What I mean to say, it has to have an internet point. There should be a Wi-Fi point, a router somewhere. Just like you are connecting a laptop, you can connect a sensor. That is the thing. Okay.
Yes, sir. Yes, sir.
Am I right?
Yes, sir. Yes, sir. You are right.
So you are just connecting a sensor through a Wi-Fi network. So this ESP32 is a computer. You can do some computing. Also, it creates a it gives you access. Just like you connect Wi-Fi, your laptop has a Wi-Fi a protocol which will connect. Okay.
Right, sir.
Everybody can access your Wi-Fi. So just like that, on the small chip, so the protocol is embedded. Okay. So just you will see when I'll teach you serial communication, this is, you can say, a sort of wireless serial communication. Okay.
Yes, sir.
Okay, go ahead, please, Ranit.
Okay, sir. Sir, this is the our access point, and now another student has asked me that if we want to catch the Wi-Fi from our Wi-Fi router, this is our the next things be there. We will catch the Wi-Fi signal from our Wi-Fi network. Okay, and then you can send your data to your cloud. This is another part. This is server. Okay, and this is cloud. Both the things are different. This is server part. I will show you the server part in the remaining next class. And now today we are showing the cloud based part, how we can send the data to cloud. We are using things with cloud. Okay, so now I am going to the next part, next topic. Now how do we catch our Wi-Fi signal to ESP32, and how do we send our data through Wi-Fi to cloud, right? So okay, this is our next program. So this is Wi-Fi based. So now I have just blocking some lines. Give me some time. Just blocking. It will be required, not required to develop Wi-Fi connection to your Wi-Fi ESP32 board. Not things people will be required. Okay. What I am using, I am including Wi-Fi.h. Okay. Then we have to we have to select a serial.begin 9600 baud rate, because we want to see our message to our serial monitor, it is connected or not, what is our Wi-Fi network IP. So that is why serial.begin is required. That is, this is UART protocol I have said earlier. First, you have to use one function, Wi-Fi.disconnect. Why? Because if you are not using this function, suppose I am using ESP32 in my one router. Now I am moving one my room to another room. There is another Wi-Fi router is there. This is far away, and this room has another Wi-Fi, and another Wi-Fi name and Wi-Fi password is there. It is not connected because you are not disconnect the previous things. You have to forget. You have to remove this previous saved Wi-Fi name and Wi-Fi password. Okay, so that is why you are required the Wi-Fi.disconnect. It is required. It must require. Okay. Then you have to print serial.print searching network. This is our window like a eye-catching, and this is the presentable format. Searching network is there. When you are using Wi-Fi, you are clear. You are just searching button is pressed. The searching thing, one thing is just clocking is rounding like that. So this is the thing. This is nothing else. This is the presentable format. I have just printed. The searching network will be printed. And this is Wi-Fi.begin. Wi-Fi.begin there should be two things in bracket. First is what is your Wi-Fi name, which Wi-Fi you want to connect. Those who are in home and you are using, you can use your mobile network also. You are using, you can open your hotspot and enter here your hotspot name and hotspot password. You can. Also, you can your router name and router password. I am using my lab router. This lab router name is Moto G3, and the password is 8 times 0. This is very easy password to remember. So that is why we are putting. So after Wi-Fi.begin, just use a continuous means infinite while loop while it is not connected to this network. That means Wi-Fi.status gives you throws a logic 1 if it status is connected. It throws 0 when it is not connected. Okay, so when throws is 0, zero's complement, I have just complemented it. This exclamatory sign is complemented. Complemented means that is not equal. Okay, so zero's complement means 1. 1 means true, while loop is going through again and again. This is true. When while loop will break if Wi-Fi status is connected. When connected, it throws a result 1. 1's complement means 0. 0 means the while loop will break and going to the next part. When it is not connected, serial.print 3 times dot, just it is a presentable format and nothing else. 3 times dot, delay something, again print 3 times dot, just in presentable format, nothing. After completing this while loop, again serial.println means this line searching.network. I just want to press enter, nothing. Serial.println means just press enter. Again serial.println connected successfully. This is the message, is connected successfully. And serial.print just print your IP, which is your internet protocols address. It will be printed. Okay, next line will print internet protocol IP. Just I am uploading this program to my ESP32 board and I want to see what is my IP and it connected successfully or not. Okay, just upload it. First, I am not checking COM port is connected or not. Yes, it is connected and COM port we should turn off. We have to wait some time to compile it. Yes, it is uploading. This is connecting as things will be there dot printed. I don't know you have noticed or not. This is this presentable format. Okay, so the program is uploaded successfully. Now I have opened my serial monitor. Serial monitor open too late, so that is why it is not printed connected successfully or other things. Just I have pressed enable button, means reset. Searching network connected successfully and it is showing my IP. What is my IP? I have connected my router. Router connection start with 192.168.0 and it can support 0 to 255 connection, different connection. So that is why it generates a different connection. So I have connected one IP 103, right? So that is in this process you access the Wi-Fi. Previous things is that you generate Wi-Fi. Generate Wi-Fi means hotspot type. You can compare, and this is receive the network. Okay, I am just receiving. This is generating access point. Access point has another application. It has another application. I am showing you today the Wi-Fi application. How to you can send your data to cloud, right? In this, up to this, you have any doubt, any questions is there? Now I am going to ThingSpeak. If you are facing any doubt, any questions is there, you can ask. Okay.
So like in the first demo that you showed for IIT KGP, that was like it created its own Wi-Fi and for
Right.
receiving.
Right.
Okay.
Sir, between both the methods, like creating own Wi-Fi or connecting to other, which is preferred? Like if we want to send data from the sensor to the other computer or server.
Yes, this is not preferred. You have to choose your task or preference. You want to send a data your Wi-Fi through Wi-Fi to a cloud, then you can use Wi-Fi access, and then you can send your data to cloud. If you are using your own server means your local server. Okay, this is not cloud. If total power is shut down and this is turned off, it may lost your saved data. Both the things have advantages and disadvantages. Advantages in the cloud is it is secured and it is permanently saved, and it has a problem. You cannot send the data continuously. ThingSpeak allows us 15 seconds delay. If you put a data, after 15 seconds you can put another data. In the meantime, you cannot put any data. Okay, so ThingSpeak tells us you must save the data which is important, not all the data. Okay, so you can upload it like a temperature. If the temperature is 25 degrees centigrade in 1 second, you don't have to send the one up after 100 millisecond the temperature. 100 millisecond the temperature will be the more or less same 25 degrees centigrade. You can send the data after 15 seconds. It is not a problem, not a issue, right? So you can compute your result, or you can use your algorithm, or use your you can collect the data, you can use the plots, and you can FFT it and DFT it, you can generate your suitable things. Then you can upload this suitable thing to your cloud, not all the things, right? So that is why we are using we can use access point. We will see you later. Okay, and today we are using ThingSpeak. How to use ThingSpeak to send your data to cloud. Today I am showing a normal data to how to save it, because of we want to learn how to use ThingSpeak. After getting comfortable with it, then we can go for various programming like temperature sensing, humidity sensing is there, and we can save it. In a total day, we can save 6 times of temperature in the morning, and 10 o'clock, and 12 o'clock, and 2 p.m., 4 p.m., 6 p.m. like this. In this instant, we can save that our today's 24 hours temperature record, not all the times. So that is we are using ThingSpeak. We can use ThingSpeak because it is very much far from 15-second time interval, right? So now I am unblocking something. Let's not unblocking something. I am seeing you something about ThingSpeak. You can say it thoroughly, and you can record it. Just you can open ThingSpeak, ThingSpeak. Enter. This is the free cloud which you can use student, and it also paid platform is there. This is very costly. You can use like this. Click it and just create a IDs there. Just click sign in. You can create it with MathWorks, and if you have account, no problem. If you don't have account, just create it account. Since I have account in MathWorks, so I am putting email ID. Just click next. Just log in into the ThingSpeak. You just create your account. This is free, and then you have to sign in to the ThingSpeak, right? Up to this, you have there is many YouTube guides and blogs are there. How to create ThingSpeak account? You can just create it, because I have already account, so I don't have to. I have no option how to create the new account. Okay, so after logging this, you have to create new channel where we can show our data and save it. Clicking this new channel, name it. How to what is the thing you have to plot? Just I am showing number, nothing else. this number I want to plot. I send a number, suppose 1, it will be printed. After 15 seconds, it will be 2, it is printed. Just I am comfortable with ThingSpeak, nothing else, right? This is the field level 1. Field level means this is a window. There are 8 window gives ThingSpeak. 8 window means like a MATLAB plot, 8 plots you can see simultaneously. I want to see it 1, not other fields. If you can use another field, I am showing 2. Okay, so I'll give it the field name. Field name is like this, the first embedded system. Embedded system is not required, embedded is sufficient. And again, the second field name is KGP. It's nothing but 2 window. Then save channel. Okay, this is your embedded, and this is ID KGP. This is y-axis, nothing else. Or this is the in the channel of number. When you can use a, suppose you are using a name of your product, then you use this product name. Number means in the field you are using product name, and you can use this y-axis as your your choice, what you want to plot. Suppose I am giving you an example. In this position of number, you can use DTH11. DTH11 or DTH22 is nothing but a humidity and temperature sensor, which can use temperature, sense temperature and sense humidity. If you want to plot humidity in y-axis, under this field, you can use temperature and humidity. You can plot is like this. One plot is humidity, one plot is temperature. The name of the number at the position of the number, you can use DTH11 or DTH22. Okay. Now I am setting channel setting. Channel setting is this, the channel setting. Okay, private view. Add WHGate. So number display, numeric display you can use. Next. Updated interval is 15 seconds. If you can click it to reduce your number of seconds, you cannot create it. 15-second interval is minimum. If you can use a 5-second interval, it is not possible. Okay, it's not possible. You can change interval for field 1 15 second, field 2 30 second, field 2 means IIT KGP 30 second. You can. Okay, I am using only one channel. Other channel I am not use today. Now the interval will be 15 seconds. Just I am plotting a straight line. Straight line means 1 second it plot, like 0 second it plot 0, like 15 second plots 1, like 30 seconds plot 2, right there. Okay, create. This is very important thing. Channel ID, author, access. Access is private because it's a password protected. Channel is much required. What is our channel ID? Where it is required? Just close it. Wi-Fi connection. You have to include the library thingspeak.h. Where? Go to tools, go to manage libraries. Just include it. If you are not included, I am using this inbuilt function like thingspeak.begin. It is not, will not work. It throws an error because I have not included the library. I am using the function. What will be? Then it throws error. Just type thing. I've already installed this ThingSpeak. That is why it is showing my message installed. Otherwise, it will show install it button here. Select the version like this, and just install it and close it. Okay. So now we are defining hashtag define. Hashtag define is a preprocessor. channel ID will required. Why? You want to send a data to ThingSpeak. You have to select the channel ID where it will be printed or where it will be saved. So that is why channel ID is required. Channel ID, the hashtag defines, consumes each and everything in a number. So that is why we are just space it and paste is the number. From where? This is my channel ID. You show it. I am showing you here. I have created another channel ID. So that is why this channel ID will be it will be changed here. I'm noticing that this is 1668441. This is 1668354. So this will be, we have to change this channel ID. Copy it, just paste it. Processor don't need any semicolon. And another thing we have to record, channel API key. API key means we have two keys. One key is reading. Reading means from the server to my processor. Another is writing. I am writing here. So I am copying the API key writing. From where? This is the API keys. API keys. In ThingSpeak, this is API key menu is there.
Sir, in the channel ID, there should be only one. There are two ones.
Oh, two ones. Sorry. Thank you. Channel ID 1. In API key, write API key, we have to select. Just copy it and paste it. This is our channel API key for writing. Okay. Now I am creating an instance Wi-Fi client. I have named client as a name. You can use another name. I've used client. Okay, no problem. Then this program we have understood because this is nothing our previous program. Then just initialize ThingSpeak.begin client, the instant. This is our main instant. Now we are using a loop. Just we have taken integer int I equal to 0, and this is an increment of I while loop. This I incremented by 1 I plus plus, and we send the data ThingSpeak write field. The code is that ThingSpeak write field. We have to insert 4 things. What? First is channel ID. Then from channel ID to field, which field? 1, 2, 3, 4, 5, 6, 8 fields are there. Fields means this is the fields. This is first field, field 1, field 2. This is have written field chart 1, field chart 2, field number. And what is our value you want to write is there. The value is I. First we print 0, then we print 1, then we print 2, nothing else. And then the API key. This is writing operation or reading operation. Okay. Then we have to set not 500 millisecond delay. You have to set 15,000 millisecond delay. Why? Because we don't send any data within 15 seconds. If you send the data will miss. We will not save. I will show you. Okay. How it is missed. Now we will upload this program to ESP32. At first we have to verify any common port is open or not. Okay, it is uploading. Yes, it has uploaded. Now I am open serial monitor. It is not showing nothing. Just click reset button. Searching network. You have connected successfully. Now it has my serial network. It has nothing to show. I am interested to get my data here. At first, one data at time 9:45 and 37 seconds is plotted. Okay. Again, it has plot. You have seen it. After 15 seconds, again one data will be plotted. Wait 15 seconds. Right? 0, 1, again 2, again 15 seconds. This is ThinkSpeaks platform. How do we send my data and from one to another field? This is the number. The number shows how many points you will send here. Okay.
Sir,
okay, please.
Sir, I think there is a delay in the like change of the number in the like graph and the numeric display.
Right. Because of that, you have seen this is the straight line, because you want to send your data after 15 seconds. Why it is happening? Because this is the program. We delayed 15 seconds, right? After 15 seconds, you can send your data. Okay, it is sending. When it is sending, it consumes some time to send this data to the web server, and it also consumes it also depends on the speed of the network. Sometimes the speed will be laggy, so that is why some milliseconds gap will be there. So that is will not be problem. Why this is not will not be problem? Because timestamp will be there. Timestamp will be there. Timestamp. Okay. This will not any problem, because if there are no timestamp, then it will be problematic. This is uniform or not. I have not see it properly. If it is uniform, then it will be you can get straight line. It is not uniform. If something delays there, not you will get proper straight line. But timestamp will be there. You with respect to timestamp, you can get your data. There is any questions? Any problem? Anything? It is clear, all of you?
Yes, sir.
Okay. Next time on next sessions, we will show you how to send the data temperature and humidity, and not only the temperature, humidity, and various after calculating signal processing some data. If we want to set this data to ThinkSpeak, how to set this data and how to calculate it, we can see it in the next time. Hello, sir. Sir. Hello. I think sir left this meeting. I've just called him. After calling back, I'm giving you 5 just questions, basic questions is there from this tutorial, from this session. You can just answer it, nothing else. Okay. Hello, any TS are there? Hello. Hello. Hello.
Yeah, Ronit.
Yes, I have completed my presentation today for today. I want to upload 10 questions, assignment questions is there, and they just answered it within this day. Is it possible?
By when they should answer?
I have uploaded a question set from here in the files section, and they just answered it. This is possible?
No, actually we have to create an assignment. So you can send me the question set. I'll drop you email, my email address in my
Okay,
MS Team.
okay, okay,
Then
okay.
I'll create the assignment. So by today they should submit or by tomorrow.
Okay, okay. I am sending you. Okay. I am sending 10 questions. 10
Yeah, you
questions.
send me the 10 questions in MS Team. That would be better. I can directly create the assignment.
Okay, okay. Thank you. Thank you. Now we can leave this
Now,
meeting
yeah,
and
now we can
call it
close
a
the class.
Okay.
Yes,
Okay.
yes.
Thank you.
Sir, what would be the deadline for the submission?
Patito Pavan sir will tell you this is only, I think, 2 minutes.
I'll check it and create the assignment properly so that it will no, the deadline is proper, and I'll ask sir and I'll create the deadline.
Okay, sir.